Hope we can start now. Can you hear Babu sir?
Yes,
Can you switch on your mic?
Yeah. Can you hear me?
Yes.
Okay, good.
Okay. Dear friends, today we have all assembled here for an invited lecture on development of lithium ion batteries. It is a very important subject. The lecture will be delivered by Mr. P.K. Babu, Dr. P.K. Babu. Presently he is the professor and graduate program coordinator at Department of Physics, Western Illinois University, Macomb. Mr. Babu obtained his PhD in experimental solid-state physics from Indian Institute of Science in Bangalore, India in the year 1995. He worked in the field of nuclear quadrupole resonance research for his PhD degree. Later, he was a visiting fellow at Tata Institute of Fundamental Research, Mumbai, India, wherein he worked on spin perils transition in copper germanate, peak effect in type 2 superconductors. And later on he continued his postdoctoral research associate work at University of Illinois Urbana-Champaign between the year 2000 and 2004, wherein he worked in the area development of CO-tolerant bimetallic catalyst for direct methanol fuel cells and electronic properties of metal and alloy nanoparticle catalyst. And then he joined as physics faculty of Western Illinois University in the August 2008. Currently, his research interests are optical properties of metal semiconducting nanoparticles confined in glass matrices. This is a brief CV of Mr. P.K. Babu. Obviously, he has published quite a large number of research papers in very well-known national and international journals. He would have also received large number of recognitions. Babu is very humble, not to mention his recognitions are any other things in his CV. Sir, that's your modest. When we invited Mr. Babu during his visit to India, he was extremely happy to accept the invitation amidst of his busy schedule. It was supposed to be an offline program, coming to our campus and delivering the lecture, which we would have also enjoyed. Due to unavoidable circumstances at his place, he could not come. He is hardly at a distance of 1 kilometer from the venue. But now we are conducting online session. That is the power of technology. We could not have imagined this a few years ago. Today, without cancelling the program, we can have the program. On behalf of National Education Society of Karnataka, National College Jayanagar, all the staff members of Department of Physics, and my dear beloved students, I extend a warm welcome to Professor Babu. Welcome to you, sir.
Thank you very much.
Okay. We have with us Saisudha Mallur, Mrs. Babu in the program. Saisudha also did a PhD from Indian Institute of Science after obtaining MSc from Bangalore University. To mention, Sudha was my classmate. She was a very brilliant student all along her student days. Even after, she is also working in the same university where the Babu is as a full-time professor of physics. Sudha, I welcome you on behalf of National Education Society of Karnataka, National College Jayanagar, and all my students here.
Thank you.
And I heartily welcome Professor H.C. Bellad, Head of the Department of Physics at National College Jayanagar, and also Mr. Ganesh Hegde, who is working behind the scenes for this program. So I welcome Mr. Ganesh Hegde also. Here we have with us Dr. P. Nagaraju, a faculty from postgraduate section of National College Vijayanagar. Welcome you, sir. I welcome all my dear students for this program. I also welcome all the participants who are listening to this lecture in the online platform. Now I request Mr. Babu to carry on his lecture on lithium-ion batteries. Mr. Babu.
Thank you very much, Dr. Kamala. Thank you for those very kind words. And I would also like to extend my warm wishes, greetings, and gratitude to National College Jayanagar for inviting me and the Department of Physics for hosting this event. My apologies for delivering this lecture in this particular mode. That was not the original plan, but I am still glad that we are able to communicate, as Dr. Kamala said, through the internet platform. So during my introduction, Dr. Kamala mentioned that I work at Western Illinois University. So for those who are not familiar with this particular institution, let me say a couple of words about that. Western Illinois University has two campuses. It is a mid-sized public university, state university in the state of Illinois. The main campus is in a small town called Macomb, Illinois. You can see, this is part of the USA map. So Macomb is here. Most of you probably heard about Chicago. Macomb is about 200 miles southwest of Chicago. You can see some other important well-known cities. St. Louis in Missouri is about 150 miles down south. Indianapolis is about 300 miles to the east of Macomb. Champaign, you can see, this is where University of Illinois at Urbana-Champaign is located, where I spent considerable amount of time as a postdoctoral fellow. This talk is prepared at a very basic level. I have tried to avoid all technical details in this presentation. So if you understand very basic aspects of DC circuits and high school chemistry, you should be able to follow this presentation. So to begin with, I will tell you an outline of my presentation. I will start with a very brief introduction to this topic, talk about traditional as well as modern energy sources that we use in our life, basics of battery, what is the basic principle of operation of a battery, importance of lithium metal, and how we arrived at the lithium ion batteries and the Nobel Prize, which was awarded to the inventors of lithium ion batteries. And finally, I will conclude with a couple of points about the future outlook for this particular field of research. So let's take some example. This is an iPhone. A cell phone has become an integral part of our life. Most people cannot live without that. The first thing that you look at, instead of even looking at your spouse, most people actually look at your cell phone when you wake up in the morning. Look at the tablet, which you guys extensively used. A nice digital camera that you probably purchased a few years ago and you really do not know where you have left it because nobody uses the digital camera these days, because cell phone can actually do everything that an expensive camera can do. Power drill tool that you buy from your local hardware store, or other examples, your dream car, the Tesla fully electric
Excuse me,
model. Yes. Yeah.
the slides are not moving. It is in the first slide. After that, it has not moved.
Is that the case everywhere?
Yes.
Yes. Yes, sir. Yes, sir. It's fine.
Because when you were showing the map, there was no map.
Oh, okay. Let me try to share this one more time.
Okay, you may have to show the map again
Okay, I will
because none
start
of
with
us
that.
could see.
Okay. Can you see the map now?
Yes. Is it in the slideshow mode?
Right now, now I have made it in the slideshow mode. Can you see that now?
Okay. No, it's not in the slideshow mode.
Is that
Sir,
what is happening with everybody there?
sir, is it possible to make it full screen?
It is full screen.
No. Uh, F5, sir.
Yeah, no, no, that is for the slideshow, right?
Yeah.
Can you see the slides moving now?
No.
Okay, all
Okay,
right.
now it moved.
Can you see? Then I will not use the slideshow and probably I will go with this. Can you see
Okay.
now?
Yeah, yes.
Okay, I have to probably go with this then.
Okay.
Okay. All right. Okay, so I was telling about, the modern gadgets that we all would like to have. It's like a Model S Tesla fully electric car. Most of you can recognize this. This is the Mars rover, which we can control by sitting here at billions of kilometers away from Mars. All these technologies are made possible by the lithium ion battery. They come in different sizes, different shapes, and different capacities. They have high potential, high energy density, and capacity. Lithium ion batteries were not developed overnight, not over months or years. It actually took several decades of intense, dedicated research by a large team of material scientists working in this field to actually come up with this marvel of a technology without which we cannot live these days. So, to mention about energy sources, we know that our grandparents used wood stove, and if you remember, until pretty recently, coal fired engines were used for trains, and we continue to use gasoline as well as diesel for powering the automobiles in our world. One common thing about all these traditional energy sources here, we are converting heat energy into mechanical energy. So, physics students, if you remember, the second law of thermodynamics states that anytime when you convert heat into mechanical energy, you can never achieve 100% efficiency because heat is a form of disordered energy. You are trying to make it to an ordered form and you have to pay a price for that. In addition to the restrictions imposed by second law of thermodynamics, a lot of heat is lost as you transfer the heat energy from its source to the moving parts in a heat engine. Then everybody knows that on top of the low efficiency, these are highly polluting energy sources. Electricity, on the other hand, after it has been invented, has become an integral part of our daily life. We use electricity for operating everything in our house as well as offices. If I were to come to Jayanagar today, I probably would have preferred the source, the type of transport on the right hand side, which is less polluting, faster, and more efficient than the one on the left. So, batteries represent a portable form of electric source. They come in all sizes and shapes. So let's look at the basic of a battery. The story of batteries go all the way back to early 18th century in Italy. The first name that comes to our mind is that of Luigi Galvani. Some of you physics students might recognize that the name Galvani is the one from which the gadget galvanometer has been derived. Galvanometer is used for measurement of electrical voltages. So here I have a cartoon of a magic show by Galvani. You can see that there is a frog hanging from an iron railing, and Luigi Galvani is holding a copper rod in his hand, and when he touches that frog, the frog will start shivering. He called it animal electricity. The science behind this would actually tell you that there was no animal electricity behind this particular phenomenon. What was happening is the following. There is something known as the electrochemical activity series of elements. You can see a lot of elements, including many metals, are listed here. If you take any pair of these metals and insert them in a solution where one of them can react with transform into its ionic form, then the electrons from that metal will move to the other metal, provided you connect them using a metallic conductor. So what Galvani was using, he had iron, which has a standard reduction potential of positive 0.77, and copper. The role of that animal, that poor frog, was very simple. It was just providing the electrolyte needed for the transport of ions from one metal to the other metal. One more thing I want to mention about this chart. You can see in this chart, the lithium has a very special place here. We will come back to this later. Alessandro Volta actually took up this idea provided by Luigi, and then he made what is known as a voltaic pile. This is a system of alternating discs of zinc and copper separated by cloth soaked in salt water. Okay, so this is a large pile. The zinc copper actually would form the electrodes of that battery, and the cloth soaked in salt water acted as an electrolyte for them. So you have a large number of batteries connected in series. Physics students probably know that when you connect batteries in series, voltages add up. So when you have a large number of these, it produces a high voltage. He was able to produce some spark with that. He went around in Europe and showed this to a lot of people, including Napoleon, who was so impressed by this and immediately made Alessandro Volta a count. A count is the equivalent of load in French. The electrochemical reactions in a Volta cell are very easy to understand. Volta cell consists of a zinc and copper electrode. Zinc electrode is immersed in a zinc sulfide solution, and the copper electrode is immersed in a copper sulfate solution. Now zinc will react with the zinc sulfate solution. It becomes zinc ion by giving up two of its electrons. Now if you connect the zinc electrode to the copper electrode by means of a metallic wire, electrons can actually pass through that. You get an electric current. Once you get an electric current, you can make a lot of work using that. And then once it reaches here, it will combine with the copper ions in the copper sulfate solution, and then that will get reduced into copper. So as the cell continues to work, zinc electrode will slowly diminish in its area, and the copper electrode will increase in the area and volume of that. This is known as a primary battery, because once you are done with the amount of zinc, you will not be able to use this battery anymore. This is not a rechargeable battery. Rechargeable batteries are actually the ones that we are looking for, because once you have a battery which is used, and if you can recharge that again, you can keep using it. You don't have to keep going to the store and try to buy new batteries all the time if you have rechargeable batteries. So rechargeable battery principle is very simple. Battery operation, I have already mentioned you have the positive electrode, and then you have a negative electrode. Current is flowing in one direction, and ions move in the opposite direction during the operation of the battery. Okay. Now, okay, I'm trying to make it full screen again. Can you see? So rechargeable battery, once the positive electrode is completely finished, all you have to do is pass an electric current in the opposite direction. So this time electrons are moving in the opposite directions. They can combine with the positive ions, which got dissolved in the electrolyte, and rebuild the electrode that you already have. The first rechargeable battery, the one which is still being used, is the lead acid battery that was invented by Willem Joseph Sinsteden and Gaston Plante, German and French scientists. The operation of lead acid battery is very simple. All batteries operate with the same principle. Okay, you have an oxidation reaction at one electrode and a reduction at the other electrode. So the cathode of a lead acid battery is lead oxide. The anode of that is lead metal. Electrolyte used is sulfuric acid. But during the normal operation of this, both electrodes would slowly become lead sulfate. And when you charge it, you will be able to rebuild your anode electrode from that. Lead acid batteries are great for your automobiles. All the cars use lead acid batteries, and all the home inverters, they also use lead acid batteries. Without these lead acid batteries, most of these homes will have difficulty with their uninterrupted power supply at home. However, lead acid batteries are not good for portable electronic devices. Imagine that your cell phones used lead acid batteries. We can expect some of the following warnings. Please don't tilt your phone while talking, because there is sulfuric acid inside that. Avoid putting your phone inside your pocket.
It's not working.
Okay.
The slideshow mode is all stuck in the battery,
Okay.
the wet cell.
Okay. So, okay. Can you see the current one?
Yeah, 1 second. I will.
Since the lead acid batteries use sulfuric acid, you will be asked not to put your phone, especially upside down, inside your pockets. Another possible warning is that don't let children handle cell phones. That's a good one, because most people try not to instead of paying attention to their kids, they will try to give a cell phone, and the kids will put the cell phone straight inside their mouth. Most of those who are familiar with lead acid batteries actually know that these batteries, as time progresses, the concentration of sulfuric acid will change, and you will have to change the pH value by pouring distilled water on that. So you can even expect a warning which says that please be careful while pouring water on cell phones for battery maintenance. Characteristics of lead acid batteries, these are some efficiency, specific energy numbers. Typically, you can use a lead acid battery for about 2 to 300 charge discharge cycles. Then the battery electrodes will start corroding. So lead acid batteries are not good. Battery scientists started looking for different forms of batteries. The first set came by the toward the end of 19th century by a Swedish inventor, Ernst Waldemar Jungner. He introduced nickel iron, nickel cadmium, and silver cadmium batteries. Nickel cadmium battery has an iron anode and a nickel oxyhydroxide as the cathode. Again, pretty good. A better version of the storage battery came up later. That was the nickel cadmium batteries. Those who grew up in uh, the 80s might probably remember that all the camcorders and the cameras that we started using, they all were using the nickel cadmium battery. It is still being used. The high end of the nickel batteries was developed by automobile manufacturers Benz and Volkswagen in 1967. Nickel metal hydride, these were improved in toward the 90s, and these are still being used in the Toyota hybrid car. They use nickel metal hydride batteries. So nickel based batteries were far better compared to lead acid battery, but still they suffered from limited energy densities and capacities. So search continued for better target materials. And we already knew where we have to look for, because we had this chart with us. You can see the special place occupied by the metal lithium in this. So lithium metal, if you go to the periodic table, you can see that it is the third element on the periodic table. It was discovered by Johann August Orfordson and Johann Giacomo Berzelius in 1870. So lithium 3 electrons, if you remove one, then you get what is called the lithium ion. So with atomic number 3, lithium is the lightest metal with a density of only 0.53 grams, that is roughly half the density of water. The low standard reduction potential, the number that you saw in that activity series, that is an indication of how much kinetic energy those electrons are going to get when you make a battery with that. So this has the largest reduction potential, the best candidate for making a battery. Now, lithium is a very reactive metal. Whatever qualities that make lithium very good for battery are also the qualities that make it very difficult to make lithium batteries, because lithium reacts with water and air if there is water content. Most of the uh, electrolytes that we have mentioned so far, they all were water-based electrolytes. So taming lithium was the most important challenge for the battery development. Lithium is a beast. You have to actually tame that beast so that you can make lithium ion batteries. So work started in early 20th century, 1958. William Harris showed that organic solvents can be used as electrolytes, so there is no water in that. So some typical examples of the electrolytes that were used. 1969, Yao and Kumar showed that sodium ions can move in solid electrolytes at the same rate as in salt metals. You don't need even any kind of liquid medium for that. So with these ideas, people have started making lithium ion transfer batteries. The idea was to use metallic lithium as the anode. Then task was to find a matching cathode. A cathode must be a material that can accommodate lithium ions at high transfer rates. The knowledge of solid state chemists was very important in this regard. They had already known compounds known as intercalation compounds. Typical example is titanium disulfide. These materials are layered materials, a lot of empty space between the layers. Lithium ions can actually go and stay in those empty spaces. So this is where really ideal candidates for making the cathodes. So here comes the first important name. Stanley Whittingham is he's a British citizen, took PhD from University of Oxford, did some postdoctoral research at Stanford, and then he joined Exxon, which is Exxon Mobil right now. It's in 1988. Currently, he works at State University of New York in Binghamton. So in 1970, he came up with a cathode material, lithium titanium disulfide, and he came up with a lithium ion battery. It used lithium metal as the anode, and this lithium compound, intercollection compound, titanium disulfide as cathode. He used an electrolyte of lithium phosphorus fluoride dissolved in propylene carbonate. EMF was about 2.5 volts, fairly good. However, once something like that happens, industries immediately want to take advantage of this. Exxon developed commercial lithium storage batteries with lithium anode, lithium disulfide as cathode, and this material as the electrolyte. These batteries could run for about 1100 cycles of charge discharge operation. However, this was an explosive development. Why do I say that this was explosive? During the discharge process, everything looked fine, but while charging, imagine that you started with a perfectly nicely shaped, say, solid piece of lithium. Then, when you were charging it, lithium did not grow back into the same shape that it originally had. It started growing into a form known as dendrites, such extended shapes, and these extended shapes would actually grow so much and they would penetrate the cathode of the material, producing a short circuit. Short circuit means low resistant path, high current. I square R is the amount of heat, and this is an organic solvent, and it immediately caught fire. So that is why this was an explosive development. Now here enters John Goodenough. He is an American. He was born in Germany. You can see names of all famous institutions associated with him. Math major from Yale University, PhD from University of Chicago, worked at MIT and University of Oxford. Currently, he is at the University of Texas at Austin. So he came up with a different cathode material, lithium cobaltate. He was able to increase the EMF to 4 volt. However, this battery still used lithium metal as the anode, and the same problems existed with the commercialization. Now comes ideas about ion transfer cells. Do not use metallic lithium anode because you will not be able to come up with a safe device. Both electrodes are made from intercalation materials that can accommodate lithium ions. So first idea was to use graphite anode. Graphite is also a layered material. And reversible electrochemical intercalation of lithium was not very straightforward. So they were not successful in using graphite at that time. So now here comes the most important development in the case of lithium ion batteries. The Japanese scientist Akira Yoshino, born in Osaka, he came up with an anode material with much higher potential than lithium. So he got the idea that a waste material, this is a byproduct of oil refining known as petroleum coke, petrocoke, that can be used as an inexpensive and safe anode material. So Yoshino came up with a safe lithium ion storage battery using petrocoke as the anode and lithium cobalt oxide as the cathode. Sony and the company which where he worked, they commercialized it in 1991. The first commercial lithium ion battery was available for the world. So here is a chart which shows you the capacities, energy densities of various lithium-based and other storage cells. Here you can see lead is at a very low point and lithium is definitely the best battery material. Nobel Prize, The Nobel Prize in Chemistry for 2019 was awarded to these three scientists, John Goodenough, Mike Stanley Whittingham, and Akira Yoshino. John Goodenough actually was a very regular visitor at Indian Institute of Science. He's a good friend of Professor Sienna Rao. So I was fortunate to listen to him when he used to come to IISc in the early 90s. Stanley Whittingham, as I mentioned, is there in State University of New York. So, and Akira Yoshino, they jointly were awarded the Nobel Prize. Now, John Goodenough, one more thing I have to mention is that he was born in 1922 toward the waning period of the last pandemic. In July next month, he will actually be 100 years old. So in 2019, when he got the Nobel Prize, he set a record. He became the oldest human being to win the Nobel Prize. Future outlook, battery research is still a very active area. New cathode materials are coming up, and new solid electrolytes with graphite anode are currently being used. They have increased EMF and the energy density. There are still many challenges remaining. If you are looking for an electric car, battery pack is placed at the floor of the car. Main challenges that we face are the following: cost of the battery. The battery is the most expensive part of an electric car. Most people cannot afford an electric car because of that. Charging time, we would like to see the car getting charged, fully charged in about 20 to 30 minutes. We are still not there. Life of the battery should last for at least 10 years. You don't want to buy a new car every 5 years. Elemental abundances, this slide actually shows that there is plenty of lithium available in the world. Our idea should be to move away from fossil fuels. Here is an example: Cochin International Airport in India, completely powered by solar electricity. Not only that, the airport, even the neighboring villages receive electricity from here. Cardinal Point Wind Farm, McDonough County, is the place where Macomb is located. Wind farm is the fastest growing industry in the state of Illinois. Both wind and solar are great renewable energy sources. However, they are both weather dependent. If you have overcast sky, your solar cells will not work. If there is no wind, the wind turbines will not move. So it is very important that we have safe and affordable battery technology which can store the energy whenever these things are working properly. Finally, I will leave you with one remark, one particular difficulty that all of us face with our batteries, and that this is a challenge which we still cannot come out of this particular challenge. I would like to thank Dr. Kamala and the National College, Jayanagar, for this opportunity. All the students and faculty who came to attend this talk, and I would also like to thank friends and family members who joined this presentation. Thank you. If any of you have any questions, I will be happy to answer them.
And later on, we can leave the session for question and answer, unlimited.
Yeah. My apologies for the technical difficulties that we had.
It's okay, it's okay. We missed you having in our campus.
Okay.
Okay. Good afternoon, everyone present here. It gives me an immense pleasure to deliver a vote of thanks for this event to all assembled here. I would like to thank today's speakers, Dr. P.K. Babu and Dr. Saisudha Mallur, professors, the Department of Physics, Western Illinois University, Macomb, Illinois, USA, for visiting and enlightening our students with their knowledge. Today lecturer on development of lithium-ion batteries, technology that revolutionized energy storage, was full of knowledge and interesting things. It gave deep insight into the topic and also revealed some interesting facts. I'm pretty sure that the precious knowledge shared by today's speaker will definitely help our students in their studies and future. Once again, I would like to thank today's speakers for taking out time for their busy schedule and sharing the information with our students. I would like to express our profound gratitude to our principal, Dr. Y.C. Kamala, for giving permission to organize this event. I am happy to express a vote of thanks to all UG and PG staff members who made this event grand success. I would like to thank BUJ Science Center staff, especially Asif, for his technical support. Last but not the least, I would like to thank all the students for paying your attention and learning. Thank you one and all.
I thank Professor H.C. Bellat, the head of the Department of Physics at National College, Jayanagar, for working all along for this program. Now the session is open for discussion for both the participant, online and offline. Even the online participants, please, you can ask questions.
You can use the chat feature of the Google Meet if you want to type in a question.
Sir, good morning.
Good morning.
And your presentation is excellent. There is no doubt about it. Even our students would be able to understand each and everything what you have mentioned. My basic question is, of course, I call it as a silly question. Galvani, I read somewhere, was a medical doctor. He was doing some experiment with lizards. And I also read that when the lizard tail was cut, it started jumping. From there, he got the idea of current. Could you just enlighten about that experiment which he did in the initial stage, please?
Okay. First of all, I have to say that what you said is absolutely right. Galvani was a medical doctor. He was not a physicist or chemist. That is why he thought whatever was happening was due to animal electricity. When I showed you, the electrochemical series, if you take any pair of metals and you insert them in an electrolyte, you will be able to initiate an electrochemical reaction producing electricity. So he was holding a copper rod, so the metal is copper, in his hand, and that frog was hung from a steel railing that is predominantly iron. So you have two different metals, and then the frog actually acted as the electrolyte in between the blood of the frog, that has dissolved salts, that was actually able to initiate the electrochemical reaction when he poked the frog with the copper rod that he had. That is when, the frog started twitching at that time. He was a medical doctor, absolutely. Which battery is best? Lithium-ion battery. Right now, lithium-ion battery is the best battery that we have. You can see that for most of the portable electronic devices, your cell phones, whatever laptops, all of them, the existing technology for lithium-ion battery can actually serve the purpose. Definitely, there is a lot of research going on to improve the energy density and capacity of storage batteries. So the battery that you mentioned, sodium-based, is one of that. It is still at the research level. Probably we might be able to use large-scale sodium-based storage batteries whenever we are dealing with wind and solar energies. Right next to that, we can keep those type of batteries, but they are still at a very young, early stage. Good question, though. Yes, you can work with magnesium battery. You are right.
Good afternoon, sir.
Good
This is
afternoon.
Satvik Sharma from 6th semester BSc. So can you please enlighten us about how eco-friendly we can destroy batteries?
Oh, this is a very important point. Thank you for bringing this up actually, because, right now, this has some commercial interest of all the factories involved in making lithium ion batteries. Most of the lithium that we get are extracted from a couple of mines in the world. The largest lithium ore deposit is in Atacama Desert in Chile, South America. Largest exporter of lithium is Australia. However, if we cannot come up with a robust plan for recycling the lithium, we are actually not going to make it eco-friendly. So the biggest challenge, one of the biggest challenges that we still face is to come up with a very real robust plan for recycling. Nobody should throw your batteries, even the ordinary batteries that you have. All the lithium ion batteries must be recycled. However, most of the factories are still not using any recycled lithium. So this, we really need to do a lot of fundamental research to come up with inexpensive ways of extracting lithium from used lithium ion batteries. Very important point.
Hello. Sir,
Yeah.
one question from message section asked by Pooja Mohan. Sir, which battery is best, Leon battery or Na battery?
Oh, yeah. I mean, I already saw that question. I answered. It is, she was asking about lithium or sodium batteries. Right now, lithium is definitely the best, but sodium may replace that in future. Any other questions, comments?
Hello. Thank you, sir.
Hello. Yeah. Yeah. Yes, please.
I have a question.
Yeah. Go ahead.
Sir, in the recent days, there are some electric bikes are there. So, sir, the production is, when I went to that shop or showroom, they told that the batteries are coming from China. Okay. So,
Yeah.
but why they are not telling the secrets of battery production in India? And if I want to buy a new battery, they will tell that they have to come from China and you have to wait for 6 months. So why can't it be produced in India rather than China or any other country? Is there any idea or
This
answer?
is, of course, you get cheap labor in China. That is the main reason why a lot of things are manufactured in China. Other than that, the socio-political reasons behind that are not known to me. My feeling is that, cheap human labor, availability of that is the main reason why they are being produced in China. And also, lithium is, if you look at the lithium deposits in the world, India does not stand in the top 10 of that list.
Thank you, sir.
I have shared my email ID if you have any other questions.
Any questions?
Any other questions from anybody?
Bella, sir?
Hello?
Any questions from online?
I don't see any.
Hello. Sir, can you please share about further research options in this field, where we can study it in India and also?
Okay, so of course, alternate materials other than lithium, one of the students already mentioned sodium, magnesium, etc. And also another one which, I casually mentioned about the recycling of lithium. That is something which is important research that somebody can take up. How to extract lithium from used lithium batteries in inexpensive ways. Okay, there is another question from Pooja, research scholar. I am doing work with energy storage device. I am still confused which adopt a supercapacitor or battery. Battery, depends on the application that you have. Supercapacitor will give you some large amount of energy quickly. Okay, you want to say for example, sometimes you want to charge your batteries very quickly, you can use a supercapacitor array for that. On the other hand, if you are looking at uh, applications like an electric vehicle, electric battery is the way to go. Both of them are energy storage devices.
Hello, sir. I have one more doubt
Hello.
that, sir, in these days there are some polymers, polymer batteries are coming, and especially about sodium chloride and some other chlorides. So, is it affordable in recent future, or is it not?
The work done on polymer electrolytes are still in the elementary stage. Advanced basic research is done in polymer electrolyte based batteries. So we may have to wait for a few more years before they will be used in commercial batteries. If you remember the talk, the lithium ion batteries took so many decades before they came to the current form. So like that, we may have to wait for many, many years until we gather enough data to come up with polymer based. Polymers are, polymer electrolytes used in these batteries.
Thank you, sir.
Any other questions, please? If there is no questions, then I hope we can conclude the session. Asif, please display the screen. Okay. Yep. Okay. Yes. You have? Baba. Yes, there is one more question.
Yes, please.
So which one might be good, sir? Hydrogen vehicles or electric batteries?
Electric batteries. Even though hydrogen is a very clean source of energy and hydrogen is the most abundant element in the universe, pure hydrogen is not available in that form on our planet. Okay, atmosphere has very little amount of hydrogen, luckily, because if you have so much of hydrogen, if you just strike a match, your atmosphere will entirely burn. The hydrogen that we are currently using for applications, they are extracted from some marsh mines. It is the natural gas, contains larger amount of hydrogen. We have to purify hydrogen from that. Hydrogen has to be in extremely pure form if you want to use it in a fuel cell. Okay. So pure form of hydrogen, to make it is an energy intense process. So you will not be able to get more energy than the amount of energy that you have spent in purifying hydrogen. So right now, battery technology is the better one option than hydrogen fuel cell.
Sir, thank you very much. We had a very good discussion. Probably during your next visit, we can have a offline program where our students can interact with you apart from the regular classroom and the lecture. They can also interact with about your university and the related program. So if you can highlight to our students what is the nature of programs that are going on in your university, it's away from the regular lecture, that can be briefed about.
Okay, thank you, Dr. Kamala, for asking me that question. So we have an undergraduate program, physics major, like in any places, it's a 4-year degree BS. And we also have a master's program in physics. Our master's program is ranked among the top master's programs in the United States. You know, where institutions where master's is the highest degree, we are actually ranked the #1 master's program in physics at Western University. We get a lot of students. We get applications from all international students. Also have some graduate assistantships, limited number available for our students who are selected for this program. It's a 4-semester program. A lot of students study there, students from Nepal, students from African countries, etc. Then continue their PhD school because it is taken as a stepping stone for them and it works out quite well for them. And some of those students actually take up industry jobs. So our master's program is a very attractive option if any of you are thinking about joining for our MS.
You can also brief about what are the parameters to assess for scholarship.
Okay, the scholarship is currently based on your undergraduate GPA and you know what kind of so you have to have America, they calculate the GPA on a 4.00 scale, so you must have minimum 3.00 or above as your GPA. The better, you know, the higher the better. So if you have 3.5 or better, you stand a good chance of getting an assistantship for the program.
Roughly above 80%.
No GRE is required. We have stopped.
Oh,
using
that's
GRE.
good. So it is a direct application then. It is a direct application to university and roughly above 80% is for the scholarship in case of percentage.
That's correct. Yeah. It's a direct application to the university. If you can go to the university website and the School of Graduate Studies, there are links that will direct you to the application process.
Hello, sir. One question from message.
On the chat, working on batteries? No, I am not. I am not working on BA batteries.
Okay. There was a question?
Yeah, on the chat.
There was someone else speaking in the mic. Okay. If there is no question, we can thank the speaker once again. Thank you, Professor Babu sir. Sudha, thank you very much.
Yes.
Thank you.
Thank you.
Thank you, Dr. Kamala. Thank you very much
Thank
for this
you.
opportunity.
So
Thank
hope
you.
we shall meet the next time.
Yes.
Thank you.
Thank you. Bye.
Thank you.
Bye.